All right. Oh, look at that. That camera was too close up, wasn't it? So this is a different room. I don't know how I feel about this room. You know what I'm saying? The board's not as big, but hey, hopefully it works for you. How you doing? What's going on? Getting a little late start, but hey, better late than never. And today, let me go ahead and set my little timer for my little 25 minutes. So I told my friend I was gonna make him a video, and he said on completing the square. So Kenny, hold on, Kenny, here's your completing the square. All right. Okay. All right, so when we're talking about completing the square, I want you to think back to, and now mind you, for those of you that haven't done this, this is cool, it's okay. We're jumping ahead a little bit. You may not have done this already. I know I was going in order, but like I said, I also take requests. So if you have a request, let me know. So when we talk about completing the square, we want to base that off of, go back to the square root property. Right? Because you know, on the square root property, you had the situation where in order to solve one side, you end up with one side squared. And then, right? So you had something like this. X plus k squared is equal to n squared. Right? So that's like the square root property. Oh, sorry. Not n squared. Because we would take the square. So you would know that you would have to take the square root. And so let's just say that, so we can write the left side, this left side before we get here. We can expand that out, okay? And it could be a perfect square trinomial. And so when you have this side as the perfect square trinomial, then that's when you're going to use that completing the square, because we want this side to be squared, okay? So we write the left side of the equation as a perfect square trinomial that can be factored into a binomial that says that it's squared. Remember that? Think about that, okay? And so this is what we're doing when we are completing the square. So let's just say we had x squared, what is it? Is it, I think plus 10x plus 25, right? So we have this trinomial here, regular trinomial. Well, we can rewrite that, or we can factor that, right? You want to call it factor, because this is actually factoring, but you can also rewrite it as such. Remember, this is a perfect square trinomial. So how do we know that? And I'll remind you real quick. This means x plus 5 times x plus 5, and we know we FOIL x times x, right? X squared, x times positive 5, 5x, 5 times x now, and I usually like to do that one underneath. This one goes here, that's going to be plus 5x, and then this goes here, plus 25. We combine our like terms, x squared plus 10x plus 25. So we started by, we're rewriting that perfect square trinomial as a perfect square. Okay, so we know we have your first term, your second term, your third term, A term, B term, C term, right? Remember that. Nothing changes, rules don't change. So even when we were doing our perfect squares and stuff like that, we still have A term, B term, and C term. So our polynomials, nothing ever changes. It's still A, B, C, right? Sometimes it'll be X, Y, Z, A, B, C. So in this trinomial, we know that the coefficient of X is 1. In this one, for the first term. The coefficient of X in our B term is 10. And the constant term is 25, right? So when we are talking about completing the square, what we do is we take half, back to the camera, right? Half of the coefficient of the b term. So half of this, half of 10, since 10 is b, we're going to do 10 and we'll divide it by 2, and that equals what? Right? So we're going to take half the coefficient of that b term and then square that value. Right? So then that's going to be 5 squared, which would lead us to what? 25. And then we add that value typically to both sides of the equation. Add to both sides of equation. Now, sometimes you won't see a two sides of an equation. You might see something strange as if they come along right here and do plus 25 and then minus 25. And that's the same thing, because if you add it and you take it off, then it's zeroed out, right? But you would still have to then put an equals and do the minus 25 on that side. So here's your rules. When we are solving a quadratic by completing the square, we need half the coefficient of the b term, whichever term is in the middle, and we need to square that, and then we add that value to both sides. So in this, I didn't add it in this one, but if this 25 wasn't here, we would add that 25. So let me show you this in action, okay? My board's a little small, so you have to work with me. Okay, so I'm going to erase all of this, and we'll get to one of the equations. So I'm going to take my values out of here, but I'll leave this. Half the coefficient of the b term, square that value, and add to both sides. So, let's take something, let's start off a little simple so we know what's going on. We got x squared, what is it? Plus 8x plus 10, and we got that equaling 0. And so right now our directions are going to be to complete the square or solve the quadratic equation by completing the square when the coefficient of our a term is 1. Brought my water today. Okay. All right. So when we have it like this and we already have an equal setup, remember because I said and add to both sides of the equation, right? Two sides, this side and this side. So when you already have a value right here, you're going to make room for that piece that you're at, right? So I have to make room. So in order to make room, I'm going to go ahead and move that 10 over to make room for the new value that I'm getting ready to add. So to make room, plus 8x, and then I'm going to do plus, and then whatever this is going to be equals. And now I had to move this 10 over to the right side of the equals. So it's on the left, it moved to the right, so I had to subtract it because it's positive. Now it's negative. Whatever you do to one side, you do to the other, right? That was on our last video. So now I can start to complete the square, right? I'm going to take half of the coefficient of the b term. My b term is 8. Half of 8 is? Yes. And 4 squared is what? That means 4 times 4 is? Perfect. So, 16 it is. And if I add 16 there, I'm going to add 16 over here. Okay, so now that I've done that, I get to come along over here and I can rewrite this polynomial as a perfect square polynomial. Remember, this is based off of the square root property. Remember, if this side was squared, you had to take the square root or you had to square it to get to the answer. This should come after your square root property lesson. So now we know that this is x plus 4 squared. And that equals what is negative 10 and positive 16. In case we can't remember, we have us a number line. Let's see if we made enough tallies. Negative 10. We have to go to the right 16. Oh my God, did I make enough tallies? Oh my gosh, you guys, I don't know if I did. Let's hope so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yay! Negative 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Positive 1, 2, 3, 4, 5, 6. Which I'm sure most of you know, but in case, this is the process. Right? So it equals positive 6. Now, what do we do to solve a squared value? What's the rule for that? In order to get rid of something squared, we have to do what? What's the opposite of squaring something? Remember, everything has an inverse. Say unsquaring it. Yes, you are correct. It is called unsquaring. Just kidding, it's called square root. So now we have to take the square root of this. Right? So we have x plus 4 squared. We're going to take the square root of that, and whatever we do to one side, we have to do to the other. So we'll take the square root of that. Right? And then we know squaring and square roots are inverse operations. They cancel out each other, right? So now we know that this and this cancel each other out. So we get x plus 4 is equal to the square root of 6. Okay, telemarketer. Excuse that, guys. No biggie. Okay, so now are we done yet? We're almost done. Not quite finished yet because we need just the value for x. So then we're going to move it over. Right, and we get x is equal to negative 4 plus the square root of 6. How do I know it's positive? Because there's no negative in front of it. Right? And honestly, because it's a square root, we know it could be plus or minus, right? And we know that because a negative times a negative makes a positive. So we could have negative 4 times negative 4, and that equals positive 16, or positive 4 times positive 4 equals 16. Just giving an example. Point is, it could be negative or positive because both negative value squared will make a positive value. Positive value squared makes a positive value. Right? So your final answer is going to be right here. Right? And your teacher might want you to separate it. So you would either have negative 4 plus square root of 6 or negative 4 minus square root of 6. Okay? You can have one of those two answers depending on how your instructor prefers it. Helpful? A little bit? All right, so let's jump up to one of these where our A term is not 1. What do we do when A is not 1, right? So I'll show you. And hopefully, can I erase these directions now too? You kind of got that down. Half the coefficient of the B term, then square that value and add it to both sides of the equation. Got that? Write it down. Half the coefficient of the B term. Don't worry about your spelling. Square that. Squared. Add it to both sides. So even if it's a negative, you know, you just be doing plus a negative value, right? Okay. All right. So I'm going to take this down now. And if you didn't get it, rewind it. It'll be there. And real quick now, let me see if I can knock one out for you that has your leading coefficient be something other than 1. All right. So on this one, I see a 2x squared, right? Minus 4x minus 5 equals 0. All right, so what do we do when our leading coefficient is something other than a 1? It's a little different, right? Because usually we're used to the first one just being x squared and we know that coefficient is 1. But in this case, we have something that's not a 1. What do? Very simple, y'all. Very simple. Don't panic. Don't panic. Get rid of it. You can't do completing the square if your leading coefficient is not a 1. Again, you cannot complete the square if your leading coefficient isn't a 1. Okay? You cannot. You have to first make your leading coefficient a 1. Right? And how do we do that? Well, we just divide by whatever the leading coefficient is, because that number divided by itself always makes 1. You just remember to divide the entire equation by the leading coefficient, not just that leading coefficient term. It has to be the entire equation by that leading coefficient, okay? So, got that? Okay. Cannot. And remember, rules don't ever change, okay? So, first thing we're going to do is, of course, do just like I said, and divide everything by, what's our leading coefficient? This 2, right? So both sides of our equation, we're going to divide all of this by 2, and I want to divide all of this by 2. The cool thing is that when you divide 0 by 2, it's still 0, right? So 2 divided by 2, and for you, those of you that are questioning, we have 2x squared divided by 2 minus 4x divided by 2 minus 5 over 2 is equal to 0 over 2. All right, just so we're clear, just want to make sure everybody's on the same page. So we know that that's going to leave us with x squared minus 2x minus 5 halves equals 0. All right, because we divided everything by 2. And we're going to move our 5 halves over like we're supposed to, so we're adding 5 halves to both sides so we can make space for our new. I'm just bringing my equals down. It's good to keep them lined up if you already have it. So now we have x squared minus 2x plus something is equal to positive 5 halves. So far so good? All we did was make sure that our leading coefficient was 1. Then we did the same thing. We didn't even do that yet. Then we just moved our 5 halves over. That's all we did. Don't see fraction and be like, fraction. It's okay. It's okay. You got change in your pocket. You use fractions all day, right? You say the words almost. You say in a minute. You say halfway. If you say any of those words, you're using fractions, okay? So now, half the coefficient of the b term. What's our b term? Negative 2. Doesn't matter about the negative, right? Because we're going to square our value. So even if we did take the negative, a negative times a negative is a positive, right? Half the coefficient of our b term, half of 2 is, and that value squared is, 1 squared is 1. And add it to both sides. Right? So now we have 1 added to it. Now, we have fraction rules right here, right? Tell me what this fraction is. Tell me how to convert this number 1 to fraction. What do I need to do? Because I can't add a whole number to fraction, right? That would be a mixed number. But how would I do this? Does anybody remember? Hopefully you remember if you're on this video. Yeah, I'm talking to you, friend. That's right. 1 can be written as, since my denominator is 2, then I know I can rewrite it as, right? So now over here, what do I have? Remember, because I need to make it a perfect square trinomial. So if you're ever curious, you're like, but wait, what do I do? You're going to take what you added. You had this and you did plus 1, right? 1 is what you added, so that's what's going to be squared. So yes, whatever you had you put right here is going to be what's right here, and that you're going to put in your parentheses and square it. And that's going to equal to 1 is what? 5 over 2 plus 1 over 1. Our common denominator is 2, right? 2, 4, 6, 1, 2, 3, 4. First number we see is 2, right? So this is that process. This is me adding fractions. I'm multiplying by 1, which is in the form of 2 over 2. So I have 5 over 2 plus 2 over 2, which makes 7 over 2, okay? Which hopefully you saw that here. But for those of you that might have forgotten, because you know this is the killer in math. All right, now I've gotten here, and what do I need to do? In order to make that squared go away, I have to take the square root of it. And whatever I do to one side, I have to do to the other, right? So if I have x plus 1 squared here, I got to take the square root of it. And that means I got to take the square root of 7/2. Now this might get a little bit more tricky for you guys, because I don't know if you remember your rules for radicals, right? So I'm going to erase this half over here. I'll leave this up so we can see what's going on. Let me erase that though. Okay? So down here, we know that these two cancel each other out now, right? So we have x plus 1 is equal to, did you know, make sure you know this information. How much time I got? 3 minutes. Did you know that this can also be rewritten as, better know that. And did you also know that you cannot have radicals in your denominator? But before we get there to the radicals in your denominator, we're going to go ahead and move this 1 over, okay? Because who knows, it might not end up being, oh, it's probably still going to be 1. Did we move this 1? Oh, we moved that other 1. Now we got to move this 1, right? Okay. So now we're going to, this is just a reminder, we're going to subtract 1. Oh no, that has been, you know, I always got to do something goofy like that. So we're going to subtract 1 from both sides. So now we have x is equal to negative 1 plus square root or minus 7 over 2. You're like, oh, I'm done. But again, remember I told you that this and this are the same thing, right? One says, and the other one says, same thing though, right? Okay, so we cannot leave this in this form though. So we have to break it up. You can't have a radical in the denominator. This right here, that square root symbol is called a radical. You cannot have a radical in the denominator, right? So I'm going to go ahead and rewrite it as root 7 over root 2. And I know that I have to multiply by the conjugate. Not the conjugate. It's called rationalizing your denominator. I'm sorry. I was trying to think of what it's called. I have to rationalize my denominator. Rationalize means you cannot have, like I said, a square root in the denominator. So check this out. Remember how square roots and squaring are opposites and stuff like that? This is why I'm saying you have to remember your rules. You have to know the tools, you guys. You have to know it. Because I know that if I multiply this times this, that I get, which is, right? So anytime you multiply a radical times a radical, then you're kind of squaring whatever is underneath that radical. Because then it's going to say, now I need the square root of that value. Okay? Might not make sense now, but we'll go over it later. Right now, let's knock this out. You should have an idea about this. So I'm going to go ahead and multiply both sides by root 2 over root 2. Okay? And so if I come over here on the side of my paper, here, let me change colors for you. If I'm on the side of my paper, I'm gonna change that too. And change colors. So I have root, let me just do it big. So I have 7 over 2, right? So I know that that breaks down to root 7 over root 2. But again, I know the rule says that I can't have a square root in my denominator because this is a fraction. And you can't have a square root in the denominator of your fractions. So you have to come and you multiply by, and I'm not going to say the conjugate, you're rationalizing it. So notice root 2 over root 2 is another form of 1. So I just decided to multiply it by 1 so I can change the format, because in the format it is, I can't leave the square root in the denominator. So now this becomes the square root of 14. And again, I've already told you that root 2 times root 2 is equal to root 4, which is 2. The square root of 4 is 2. That's my 25 minutes, you guys. I put it on 25 this time. So that means my answer here is actually this. So my final answer, and I'll put it back in green. I'm going to erase my side work because I just have this little bitty board to show you, but lucky you get to go back and rewind it if you didn't get to see it. So I can come over here and say x is equal to -1 plus or minus root 14 over 2, right? Because we all did this, root 2 over root 2, which equals 14 over square root of 4, and the square root of 4 is 2. Yeah? We good? A little bit clearer? I know it's a little messy on this board. This board is smaller than the other board, unfortunately. I didn't know that. But I think you still get the gist, right? We still get the basic of it, right? Oh, you know what I forgot? Did I? Let me see. Yeah, no, that's nothing. I was thinking because it could want you to add these fractions, but I don't know if I want to go into a whole lesson for you. But it does remind me, this brings up I after that, but my camera's about to stop. So put a question in the comment. You have any questions? If I made any mistakes, because I do that sometimes. Let me know if you have any questions though. Hope this helps. I hope this helps you, friend. I know you said you were still a little confused. You want to see a video on it. So if you have a specific equation that you want me to work on, throw it up there in the chat for me. And we'll knock it out next go around, okay? All right. Until next time, you all. Okay, have a great evening. Let me know if you have any questions, and thanks for stopping by. See ya.